In this video, we'll be talking about circles and the number pi. We usually represent the number pi with the symbol for the Greek letter pi. To relate circles to pi, we're going to look at two different measurements on the circle. We'll look at the circumference and the diameter. So recall that the diameter is just a line segment that stretches across the circle and passes through the center. We'll abbreviate our diameter with a d. The circumference is the distance around the circle. We'll abbreviate circumference with the letter C. I'm going to measure several circles that I found in my house, and then I'm going to take the circumference divided by the diameter, and we'll see that we can come up with a number very close to pi. Let's start out with a shout out to New Mexico with a can of Hatch green chilies. These are fairly small cans, so when I measure it, I'll wrap my measuring tape around to get the circumference. I'll record each measurement to the nearest tenth of a centimeter, so we have 21.123 right here where it wraps around. It's not a perfect measurement, but good enough for us. The diameter, I tried to pass through the center of the circle, and if I zoom in here, I have 6.567, about 6.8. So let's take circumference divided by diameter. Notice that my units canceled out, and I only copied down a few digits from the calculator, about 3.132. Let's go on to our next circle. I got a bigger can. This time I got a big can of pumpkin. And when we look at the circumference, I wrapped it around, and then I'm going to zoom in right here, and it looks like 32. We're recording to the nearest tenth, so we'll record circumference of 32.0 centimeters. The diameter, again, trying to go through the center here, looks like I'm about 10 centimeters, 0.1, 0.2, we'll call it 10.2 centimeters for the diameter. I'll take the circumference divided by the diameter, and I get about 3.137. Let's do one more. I found a big mixing bowl, and I found the circumference first. So wrapping it around, and then I zoomed in over here, and it looks like I was at 78.5678, about 78.8, not exactly, but we'll go to the nearest tenth here. And my diameter across the center, if we zoom in, it looks like I'm about right here at the edge at 25. So we'll do our calculation. And I get about 3 and 125 thousandths right here. So let's look at all of these measurements that we got. In each case, we can see that the ones place agrees, 3. We can see that the tenths place agrees, 3.1. If we were to round to the nearest hundredth, so round to the nearest hundredth, we'd have 3.13, 3.14, 3.13. We're limited here by my fault here, right? By my skill at measuring. It turns out that if I had a really accurate, precise measurement of my circumference and diameter, that this would always end up being pi. And pi is 3.14159, and it goes on. The digits go on and on forever without forming any sort of pattern. So it's a really cool thing that pi isn't just like this magic number that brilliant people came up with. It can come from measuring the circumference and the diameter of a circle. Sometimes it's handy to have an approximation for pi. 3.14 is an approximation that people use a lot. It's not exact because we've cut off some numbers. We can also approximate pi with 22 over 7, which if I put that into the calculator is 3.142857. It goes on, and so we can see that it's not exact, right? It doesn't match here when we get to the thousandths place. But if you're just doing a calculation, it might be good enough if it's one where it's handy to have a fraction. Note that pi is an irrational number. We can't write it as the ratio of any two numbers. 22 over 7, 22 sevenths is the ratio of two numbers, 22 and 7. We can't actually express pi as the ratio of two numbers. So let's go back up here to our circle. Based on the results of our rough measurements of our circle, it's totally believable that we would have circumference over diameter equals pi. We often rearrange this to say circumference equals pi times diameter. So if you can measure the diameter of the circle, just multiply it by pi and you have the circumference. We can remember that our diameter is actually twice the radius, where the radius is the distance from the center of the circle to the edge of the circle. So sometimes we replace this d with 2r, and we write the circumference is 2 pi r. So I think it's really cool that we can come up with pi, at least the first two digits, on our own just by measuring some circles, getting the circumference, and dividing by the diameter.